That's why I was like, why would you don't look under a blanket? Oh, my God, you All right, guys, I got something to do, so let's find a stopping point. Ryan, go ahead and hit the lights for me. Another day, but another time. I always record a Zoom in here, so if you miss class, you can watch the lesson. So I usually try and get all my mistakes out in C period, and then you guys, I usually can do it great. So that's why I often record. It's kind of a janky setup for right now because I'm going to use the whiteboard in a second. But that's kind of the first thing I want to tell you. I've got mostly seniors, one junior, and that's okay in here. But for the most part, as second semester seniors, we often miss school, right? You're sick, you're absent, you have college visits, you've got scholarships. Sometimes you guys just go to like senior mass and you're just not here, right? There's a lot of times that you are not present. Those of you who had me last semester, or those of you who even had me in geometry, you know that I do YouTube videos. If you go to under the good to know section, there's a link that says Miss White's YouTube page. That has every lesson ever. And I do pre-cal like every year I redo a new video, and it's often during your guys' class. So if you miss like today, you could go online and watch this video and see exactly what we did in class like you were in class. So just remember you have access to that. I also have your, oh sorry, this says G period. It's the same thing for F though. I'm so sorry. Good to know still says home YouTube page. The other thing that I think is most helpful for you guys is where is Miss White? This tells you where I am every period, every time, what room I'm in. I do not have a class during A, B, and E. So those are times that I can help you 100% one-on-one. I can sit and work and do stuff with you. Other times I have class. So like if you miss this pre-cal class, but you want to go to the other one to catch what's going on, you can do that. If you need to make up a quiz or a test, you can come during any of those classes. But A, B, and F are the only times that I can like really sit down and help you. I also have before school. After school is going to be pretty unavailable. I coach lacrosse. I'm going to be on the football field. So if you want to come hang out, I'll be on the football field, but I will not be in here after school generally. Now, will things change sometimes, or will hit practice move or whatever? Yes. So if you need to see me after school, just ask. Sometimes I can make it work, but generally not. So I will let you look at that later. If you need to come see me pretty regularly, go look at that. Generally, other than that, I put all of your material. So if you want iPad stuff, you don't want papers, our notes and our homework and extra practice sheets are already in there. Your homework assignments will be in the pink folder, which you do not have homework tonight, so there is no homework assignment. Yes. Okay. What we are going to do is we're going to do a tiny bit of notes, and then we're basically going to build the unit circle on this paper plate. Have you guys heard of the unit circle from other friends yet? Basically, we're in our trig unit, and this is a way to help us with trigonometry. Now, a lot of what we do today, you're going to have no idea what's going on, and that's okay. But if I wait till you know what's going on, it's almost too late for this. So we kind of need to build it while we're a little confused. Okay? So let's go to our notes because I want to teach you one or two things before we can get into our unit circle. So you can put your homework aside. We will not need that. We won't do anything with it. We're just going to do a tiny bit of notes today. So get it there, a pen or pencil out, or if you're on your iPad, you can use that. But we're going to start with angle, radian, and degree. Those are the only three things we're really talking about today. And you guys know what an angle is, right? Like if you look at a picture, you'd be like, I see the angle, but I think a lot of us can't define it. So I would define an angle as formed by two rays. Also, for those of you hanging on my technology journey, I did not get a new Apple Pencil over Christmas, so I still have the crappy stylus. I'm so sorry, that's on me. Hopefully I will fix that in the next couple days. I need to get one, but I just haven't. Those 4 weeks went by really quick. So thank you for your patience with me. If my handwriting sucks, just tell me, I will fix it. So it's formed by two rays and they share a vertex. So there are two rays that share a vertex. And I've got a picture right here that has all of that. So that point in the middle, that's the vertex that they share. So we can label that vertex. And then if you remember from like day 2 of geometry 2 years ago, I taught you that a ray goes from a point to an arrow. So it goes on and on forever in one direction. And then the other ray also comes from the same point and then goes on in another direction. And the angle is essentially that area in between those two rays. How do we currently measure an angle? By degrees. Very good, Chase. So if we jump down, the other two words that we talked about were radian and degree. A degree, we already know what this is. I don't really have a definition for it. It's a way to measure an angle. So I'll just say measurement of angle. And it goes from, we're going to use 0 to 360. We may go past 360, but generally we're going to go from 0 degrees to 360 degrees. So degree is a measurement of an angle, and we're going to go 0 to 360. Radian is another way that we measure degrees. So I'll just say another measurement of degrees. Or measurement of angles, excuse me. Think about, like, you can measure like the length of something. Like I've got a ruler right here. It's got inches on one side, but then it has centimeters on another side. Think of degrees and radians like that. They are interchangeable of each other, but they have different measurements. And so there's going to be a rate of conversion that we're going to use to go between them. Now, radians go from 0 to 2 pi. And we do not usually put a unit with them. We just know that they're radians. Now, while we're here, I actually have a little like GIF that Mrs. Ludington shared with me. To be very straightforward with you guys, I did not always know what a radian was. It was something that was like kind of like a weird concept to me. I still was like, I don't really know. And so I just teach it to you guys, and I would be like, no, just let it be. Just like, don't really get what it is, and let's go with that. I have this GIF now that I have here that I'm going to blow up bigger. Okay. And so basically what this does is it shows our idea of the unit circle that we're going to make in a second, and explains it in terms of the radius. So I'll just reload this GIF really quick. Basically, it starts by drawing a radius, and then it draws a full circle around it. Okay. And it labels that radius as R. It takes that radius and then curves it to go along the outside of the circle. And then it tells us that the angle that's made is labeled as 1 radius. So 1 radius comes from 1 radian comes from if I take the radius and wrap it around the outside. If you notice that top half is 3 and a tiny little bit, it's 3 and then 0.14, which makes it pi. So that whole top is pi radians. The whole bottom is another pi radians, which together is 2 pi radians. That's why when I told you on the notes, we're going to go from 0 to 2 pi. It's going to just loop it one more time. So again, we take the radius of a circle, and then we bend it to be on the outside of the circle. And the angle that's formed when we take that to be like the crust of the pizza or the pie, that angle is 1 radian. And to go a half circle, it takes 1, 2, 3, and a tiny bit, which makes 3.14 or pi radians. And then the whole bottom is also pi radians. So if you think of radians as like a length, it's a measurement that comes from the length of the radius, that might help kind of make it make sense. If not, I made it really far without having any idea what a radian was, but I thought this was a helpful visual. So I'm going to turn that one off now. Okay. Anybody questions yet? Doing okay so far? Okay. What we're going to do now is go back to the notes, because I want to talk about going between degrees and radians, and then we're going to get into this paper plane. So off to the side, I'm going to make a little note, right, like here-ish. I'm going to make a little note. Okay. What we just saw was that 180 degrees is equal to pi radians. And that's essentially the conversion factor that we're going to use to go between degrees to radians and then back from radians to degrees. So we'll start by going degrees to radians. And the way I write it might be a little bit funny, so you may want to look at it first to decide how you want to do it. but I'm gonna think about it, okay, I have a number that's gonna go in my box, that's gonna be a degree. I'm gonna take that degree and I'm gonna multiply it by pi over 180, and that's gonna get me radians. Okay, so if I have a degree, we're gonna multiply by pi over 180 to get radians. Okay, and so actually I'm just gonna pause there and we're gonna come down our paper to number 3, and it says convert to radians. Okay, what did I just say that we're gonna multiply our degree by to get radians? Pi over 180, perfect. I really want you to fight being uncomfortable and just deal with the fractions, okay? So I can think of that as 70 over 1 times pi over 180. My 70 and 180 both have a 0. They have a factor of 10, so I cancel that out. And then now I'm left with 7 and 18. Do they have anything in common? No, they can't be simplified, so I'm gonna leave it like that. It's gonna be 7 pi over 18. That's your best answer. Same idea for the next one. It says 120. What am I going to multiply by 120 to get radians? Pi over 180. Good. And again, I'm going to factor out the 120 and 180 both have a 0, so I cross that out. Now I'm looking at 12 and 18. What's the biggest thing they have in common? 6. Good. So 12 is divisible by 6 and I get 2. 18 is divisible by 6 and I get 3. So that means I'm left with 2 pi over 3. Now, before we go to that paper plate, let's go the opposite way, right? So we just did from degrees to radians. Now we're going to go from radians to degrees. Okay, same idea. This time I'm going to take a radian and I'm going to multiply it by the reciprocal of what we're just multiplying, the opposite conversion factor. So I'm not going to multiply by pi over 180. I'm going to multiply by 180 over pi. And that's going to give me a degree. Now, sometimes we see that and you're like, oh my God, that's nearly the exact same thing as what we just did above. Exactly. That's why it's a conversion factor. But once we do a problem like that, if you look under number 3, I wrote a couple other examples. It says convert to degrees, and I've got 3 pi over 5. You guys all have that on your paper. Yeah. Okay, we're going to do that one. When we decide what we're going to multiply by, think that the pi's need to go away, right? When we do degrees, up till this point, we've never had a pi with an angle. So to get rid of it, the pi goes on the bottom, and that means the 180 goes on top. So sometimes that helps me know which one am I using. I do not want pi in my degree answer, so I need to divide by pi to cancel it out. So the pi's cancel out. Now I go look, the 3 can't cancel with anything else, so it's fine as is. But 5 and 180, they can cancel with each other. I think that gives us 1 and 36. Now we're not done yet. We're going to multiply the things that are left. So 3 times 6, they're not over anything, but 3 times 6 is going to be 108. And that's my number of degrees. Now the problem next to it has 2.3. It doesn't have a pi. It also doesn't have a degree symbol, so that's how I know it's a radian. So we're going to multiply again by 180 over pi. Now, whatever they give us, we're going to give back. So if they give us a fraction, we're going to give them back a fraction. But if they give us a decimal, we're going to give them back a decimal. So let's just throw that all in your calculator. We're going to do 2.3. My calculator was being funny earlier, so let's see if it's going to be anything. I'm going to do 2.3 times 180 divided by pi. No, it's literally up there, but that's okay. And then I would just round 2 places after the decimal. I get 131.78. And again, because they gave us a decimal, I'm okay giving them back a decimal. Okay, that's all the notes on this paper that I want to do. Okay, so you can put that away, you can put that aside. I don't care. For the last 10-ish minutes of class, we're going to use just this paper plate. And I would get a pen or a pencil out. That's the first thing you need. As we go, I have colors. I don't know if we'll get to any colors today. Now, the first thing I want you to do is I want you to fold this paper plate in half and then in half again. So you're going to have 4 quadrants on here. So fold it in half. And then fold it in half again. All right, that's gonna be good enough. It's a little flat, but okay. Once you have that folded, I want you to take a pen or a pencil or whatever and trace those lines that you just folded. So you should have a vertical line, and then you should have a horizontal line. And it should be evenly split in half both ways. Oh, it looks really bad. Sorry, Zoom friends.
Well, at first you make hot dog and then you make hamburger.
Now, I'm going to tell you right now that this is just a learning tool. I'm going to give you a paper to make it all nice and pretty. So you can mess up, you can make stray marks, you can have folded it wrong. If you hate it, you can get more. I've got a million. I didn't mean to do that. I have a million paper plates, so you can use as many as you want. So don't be stressed about this. Just through it. Okay. This looks like a coordinate plane, right? Where's my x-axis? On the horizontal. So I'm going to label it X, and then that makes my vertical one the Y. I want you to label it, and it can go anywhere on the line. We're going to write on these lines a couple of things. It can go anywhere on these lines. Okay. Now, in trig, we're always going to start on the positive x-axis. So I'm going to call this 0 degrees. Okay. If I start here and this is 0 degrees, how many degrees is this positive y-axis? 90. Wow, you guys are good. 90. Okay. Then what if I go to the negative x-axis? What's this one going to be? 180. Okay, what if I go down to this negative y-axis? This one's one we don't always remember, 270. And then if I go all the way around a circle, how many degrees have I done? 360. So I'm going to put 360 up here. Okay, now we're going to use the radians that we just learned. So if you remember a minute ago in my notes, they're all gone now, but we said degree times pi over 180 gives you the radians. Okay, so now for each of these lines, we're going to write the radians. I'm going to put them on the other side of the line. Then I have my degrees. Okay, so let's start 0. What's 0 times pi over 180? 0. So 0 degrees is 0 radians. Okay, what about 90? 90 times pi over 180. What'd you say? Not 2 pi. 1/2 pi. Half of a pi. Okay. Now you might already sense a fraction pattern, but if you didn't, you could still keep doing whatever the number is times pi over 180. So I could do 180 times pi over 180. What's that going to be? Just pi. If you found a fraction pattern, notice that we went from 0 to half of a pi to now a whole pi. What do you think the next one's going to be? Not quite 2 pi. 3/2 pi. JT is really killing it back there. 3/2 pi. And then what's it going to be when I get to this all the way around? 2 pi. Good. Essentially, each 90 degrees is half of a pi. So 1/2 of a pi, 1/2 plus a half makes a whole, 1 whole plus a half makes 3.5, and then 3 halves plus a half makes 2. Something I don't necessarily want you to write, but I want you to think about. I can think about pi as being the same thing as 2 pi over 2. So I have 1 pi over 2, I've got 2 pi over 2, I've got 3 pi over 2, and then 2 pi is the same thing as 4 pi over 2. We're going to be doing a lot with fractions, so if you can make them have the same denominator, it's kind of easy to count 0, 1, 2, 3, 4 for it all to make sense. Okay. All right, the last thing that we're going to write on each of these lines is an ordered pair. So I told you this was a coordinate plane, essentially. This point right here, this point right here, this point here, and this point here, they are all special points. Those are kind of the edge of your paper plate. Do you remember what I called this a minute ago? A unit circle. Did I use that word yet?
Yeah.
Yeah, okay. It's been a long day. Sometimes when I talk too much, I don't remember what I said, but this is a unit circle. The reason it's called a unit circle is because the radius is 1 unit. So that means however wide this paper plate is, from the center to the side is just 1 unit. All the way around, every point on the outside is 1 unit away from that point right in the middle. Okay, so we're going to label these points. This point over here is going to be the point 1, 0. We went right 1 and we didn't go up or down any. I know I wrote it outside my circle. Write yours somewhere on your shape, just somewhere on this line. It could even be here. I don't care where it is. Just somewhere on your line, write 1, 0. If I go up to 90 degrees, what would that point up there be? 0, 1. What about over at 180? -1, 0. And then what about here at 270? 0, -1. Okay. We're going to do one more thing before we leave today. And it's going to be another fold. I'll give you a triangle in a second. So I did this a little bit different in C period. What I want you to do now is essentially find the halfway point in each of these quadrants. So you can think about taking the X and the Y quadrants and folding them in half to touch each other. So you essentially want to find the halfway point through all of these quadrants. So I'm going to take my X and Y axis and fold them in half on top of each other. And it should look something like this once you have it. Now I'm going to use a color for this. So if you want a color once you have your lines, I've got crayons, colored pencils, markers, and I'm going to give all of you guys a green triangle. I want you to fold it in half of this. So, like, see if you can touch it with that.
Yeah. I swear to God, I have. No. They do. Stop.
You should just have essentially 8 spots. Yeah, you look like it. Now, once you have those folds, I want you to draw to trace that. I suggest using a different color, but if you want to use pencil the whole time, that's okay. You should have a line that's like here, and then here that you folded, and then here. Oh, that's not it. If you want colors, I've got a whole bin full of colors right here. Okay, my question to you is, what's the degree here? Who knows what degree that is? What'd you say, William? 45. How'd you know that? Half of 90. Amazing. That's 45. Okay. Now, you might know, but the little green triangles I just gave you, if I gave it to the first person, make sure you take one and pass them back. Those little green triangles are 45, 45, 90. Those are special right triangles that we're going to talk more about later. What I would do with your little green triangle is label the corners 45, 45, and then a little 90 spot. So I would just make sure yours is good. We need one more. We got one under your plate. Okay, that is probably all we have time for right now. And actually, it goes like. It's gonna go like both. So it's gonna be on that next axis. So JT was just looking at his and he was trying to see how it fits on your triangle. You want or on your unit circle, the base of your green triangle should go along the positive X axis and it should fit in really nicely. We're going to talk more about that tomorrow, but I think we're in a good place. No, not yet. That dust is there. I want to go like. And so this is a reference angle, so then it also like looks down like that. And over like that. And I think that might fit that. I know nothing about tomorrow and the weather. Let me pause this for